Okay, I think we are going to start now. We are many people together in this webinar. Good afternoon to everyone and a warm welcome to this webinar. Please, before we start, note that we are recording this webinar. So if you prefer not to appear in the recording, we kindly ask you to turn off your cameras. And to start, I would like to introduce myself. My name is Lizeth Lopez, and I'm with ALDA, the European Association for Local Democracy, and it's a pleasure to be here with you as your moderator, alongside with my co-moderator, Alessandra Marchese, who will guide you during the last part of this webinar. We're really excited to host this online session as part of the COSPACE Group's joint efforts, which brings together 5 outstanding Horizon Europe projects: Magda, Respondent, Swift, 100 Trees, and Buildspace. This is the second webinar in a series of webinars organized by the group. The common thread between these projects is their innovative use of space-based technologies and cutting-edge data tools to tackle issues such as climate change, urban sustainability, and urban resilience. So to give you an overview of today's webinar and what you can expect, we want to go and have a closer look to these 2 projects, 100 Trees and Buildspace. Both are working toward greener, healthier, and more resilient urban environments, and both offer decision support tools that help planners and policymakers implement real, lasting changes in our cities. So we are going to start with a short presentation of the COSPACE Group to understand where this initiative comes from. Then we have divided our webinar into 2 sessions, the 100 Tree sessions and the Buildspace session. During the 100 Tree sessions, you will be able to explore and have an overview of the project, and also the speakers will be able to walk you through the toolbox that has been developed within the project. On our second session, during the Buildspace presentation, we will have an overview of the project and how it's advancing climate resilience and energy efficient buildings and cities. And similarly to 100 Trees, Buildspace is going to present the decision support services that has been developed within the project. At the end, we will have a Q&A sessions for all those participants that will have any questions for the speakers or for the projects in general. So this webinar is not only a space to showcase this technology innovation that we have developed within the project, but we also expected this to be a space for knowledge exchange. We expect that at the end of this webinar, we will be able to spark new ideas, raise awareness about these technologies, and opens a floor for further collaboration. We'll also explore the social impact of these efforts within the projects and how Horizon Europe projects are paving the way for climate adaptation, digitalization, and sustainability in general. So welcome everyone that have been joining us today, and we hope you enjoy it as much as we have. So to start on this, I would like to introduce our colleague, Ben Moore, who is a Senior EU Project Manager at CAR Communications, has a background in political science and international relations, and leads the communication and dissemination package for on behalf of the Respondent project. I hand it over to Ben so he can briefly introduce the COSPACE Group and how these projects came together. Please, Ben, the floor is yours.
That's great. Thank you so much, Lizeth. I'm going to just share my screen here. Give me one moment. Sorry, it's just connecting. Sorry, Lizeth, I seem to have a bit of trouble connecting. Would you mind opening my presentation just in case?
I can do it.
Perfect. Thank you very much. I'll just go with that then.
You must be seeing it now?
Yeah, perfect. That's great. Well, thank you very much, Lizeth, and good afternoon to everyone. Thank you all for being here today, and thank you to our hosts and fellow participants for making today's session possible. As Lizeth mentioned, my name is Ben Moore. I'm a Senior EU Project Manager with Car Communications Limited in Dublin, and also I am the Communication and Dissemination Manager of the Respondent Project. So the purpose of my presentation today is to give you a brief introduction to the COSPACE Group, which is a collaboration between 5 Horizon Europe projects working at the intersection of space technology, AI, and climate action. So COSPACE was formed under the Horizon Results Booster Programme, which is an initiative from the European Commission encouraging projects to work together, not just to enhance their individual dissemination strategies, but to think bigger about how their combined results can create a broader impact. As one of the partners involved in this initiative through the Respondent Project, I can say firsthand that COSPACE has really helped us to take our results further and more effectively by sharing knowledge, aligning communications, and identifying cross-sector synergies that might otherwise have been missed if we had simply acted on our own. So as you can see on the slide here, as I mentioned, the COSPACE Group brings together 5 Horizon Europe projects. We have Respondent, which focuses on renewable energy, Magda, which works on smart, resilient agriculture, Swift, which protects forest from climate-driven risks, 100k Trees, which promotes strategic urban greening, and Buildspace, which enhances climate resilience in city infrastructure. What kind of unites these diverse projects, as I mentioned, is a shared resilience on European space technologies, more specifically Copernicus Earth observation data and Galileo GNSS services, as well as advanced AI-driven modeling and in some cases digital twin simulations. Our goal as a group is to demonstrate how these technologies, when they're applied smartly and collaboratively, can support real scalable solutions to some of the most complex climate challenges facing Europe today. This spans everything from balancing renewable energy on the grid to supporting farmers in adapting to extreme weather and to help cities plan greener, healthier public spaces. So on this slide, just to give you the idea of the project at a glance, as I mentioned, Respondent is developing AI-powered tools to forecast both energy supply from renewables like solar and wind, Magda supporting climate-smart agriculture by using Earth observation data and GNSS technologies to improve irrigation planning, Swift applies satellite imagery and AI to detect risks to forests from pests, drought, storms, and fire. And then, as you'll hear more from later on, the experts here, 100k Trees and Buildspace, working on helping urban planners to use satellite data and digital modeling, as well as working on making buildings and cities more climate resilient. So then on to our next slide, why COSPACE matters, the impact and the vision. So why does this collaboration matter? With COSPACE, it's more than just about networking. Our idea was to create a shared platform for impact for our respective projects. By working together, we hope to combine our voices when speaking to policymakers, increase the visibility and uptake of our tools, to cross-pollinate ideas and insights between different sectors. What works in agriculture, for example, may inspire something new in energy, and vice versa, and to coordinate our dissemination to make our research more accessible, more usable, and more relevant to real-world stakeholders. This has already borne fruit in our joint policy brief, for example, which outlines 5 clear recommendations from investing in AI and nature-based solutions to promoting precision agriculture and data sharing frameworks, all of which are grounded in what we've learned across our projects. So COSPACE isn't really just about promoting individual success, it's about helping to shape a more connected and solutions-focused research ecosystem under Horizon Europe. And then on to our next slide. So the dissemination and knowledge sharing of COSPACE. This is really what's at the heart of the COSPACE Group, and it's been a key part of our collaboration from the very beginning. So just some of the things we've worked on has been a joint fact sheet that communicates our collective objectives in a clear, accessible way. We've really sought to coordinate our social media efforts, amplifying each other's events, milestones, and outputs, capacity building with joint presentations, speaking opportunities, and shared resources. And of course, most visibly, and why you're all here today, our webinar series. The first webinar we held in early March and was focused on Respondent and Magda, whereas today's session, which is our second and final webinar, brings Buildspace and 100k trees into the spotlight, showcasing how we can create smarter, greener cities using space-based insights. These webinars have helped us not only to reach broader audiences, but they've also created a space for dialogue and for exploring potential synergies and future collaborations between our projects, institutions, and the various stakeholders that have attended both webinar series. And then on to my final slide. I'll just end by saying thank you, not only for your attention today, but for your interest in how we can work together to tackle the challenges of climate change. I think COSPACE is really a great example of what happens when EU-funded projects such as ours go beyond their individual scopes and come together for a shared purpose, such as that promoted under COSPACE. If you'd like to learn more about COSPACE or connect with any of the participating projects, don't hesitate to get in touch. And thank you again, and I hope you enjoy the rest of today's webinar. So I'll pass it back to Lizette.
Thank you very much for that, Ben. So I think without further ado, I think we can start with our first session, which is for 100k trees. And in this session, we have the honor to have three special guests, which are Brigitte Hope Anderson, a PhD economist with over 30 years of experience. It's an expert in space applications, climate adaptation, and circular economy. She is specialized in strategic industry and sustainability assessments. Together with her, we have Niels Henrik Borch. It's a physical geographer with a PhD in remote sensing and climatology. His background is in agriculture, government, and private sector, and he's currently the Senior Business Development Manager at DHI, bringing Earth observation to water management. And our third guest is Nora van Kouwenberg. She's an expert in water and sustainability. She works globally on green infrastructure and nature-based solutions, and she is the CEO of Vita Green, an academic at the Free University of Brussels and at HE Delft Institute for Water Education. So I welcome you all three, and I will give the floor now to Brigitte so she can give an introduction to the 100k trees, the objectives, the impacts, with a specific focus on the implemented use of cases and on the monetary evaluation of ecosystem service provided to a city by trees. The floor is yours, Brigitte.
Here we go. Now you can even hear me also. That's a good thing, isn't it? I think, can you see my screen now?
Yes, we can see the meeting now.
Okay, because I had to, let me just find the presentation again. It must be in here. Yeah, okay. Right, I will put it in presentation mode. Here we go. Okay, well, good afternoon, everyone, and welcome to this webinar from 100k Tree. I will just give you a brief overview of the project and of where we are now, and then Niels and Nora will take over and present in more detail some of the results we have so far. So my name is Brigitte Holt Andersen from Seaware, which is a Copenhagen-based consultancy and research company. And we have been involved in this project from the very beginning, writing the proposal and so on. And this here, by the way, is a map of the trees in Tivoli Gardens in Copenhagen, just for your information. So the aim of the 100k trees, I mean, the basic idea has been that we really wanted to encourage more tree planting in our cities, because that's quite a cost-effective way of fighting a lot of the climate risk we are facing. So the idea was to develop some different services based on Copernicus, the mapping and modeling tools, and also try to put monetary values on the impacts of planting trees. So basically putting monetary values on the ecosystem services. And now what we are doing right now is kind of developing these business cases so that we can gather more information and have more evidence-based business cases for planting trees. And And then we are also trying to look into some novel financing mechanism to support cities in turning green. These are the partners in the project. So quite a few Danish partners, COA DHI, Belgium, Eurosense, and VUB in Brussels. Oh, I see. I'm sorry, Nora, I have missed out. Beta Green, but that's because Beta Green is a spin-off from the Freie University of Brussels, and then we have GISEC, and we have 2 partners in Sofia. And this is kind of the way we have planned the project. So we have a number of building blocks or key exportable results. We have been engaging a lot with the stakeholders, with the different types of stakeholders in the cities who could be interested in this. We have used a crowd science app, and then there are some different 3 analytics tools, Copernicus enhancement tools, and we have been looking into defining some standard trees by different tree attributes. And then what you would hear also from Nora now is that we have been developing quite some advanced models and simulations tools to understand how trees impacts the climate in the cities. And then also we are in the process of putting values of these ecosystem services. And then, as I mentioned, we are doing the tree planting business cases. So this is really where we want to, turning some of these gray concrete jungles into some more green places. And in fact, this is quite interesting. This is part of a street in Copenhagen, just outside Tivoli. So in fact, this is going to happen now. So not because of us, but because that's the way it goes. So again, this is kind of the building blocks of our projects. So we have some technical bits and pieces, the Copernicus uptake and the spatial data lab modeling. Then we have the more collaboration-based financing schemes, looking into getting inspired from other areas. And then we are trying to do the upscaling and exploitation as well. So this is how we have defined the different services in the toolbox. So there are base maps, there are 2D and 3D tree mapping, change detection, tree inventory, candidate tree planting areas, ecosystem services MAT, and also the identification of hotspots, and then the economic valuation. And we are also trying to build in the IPCC scenarios to be able to foresee where the future hotspots will be in the different cities. And in fact, we have been using Copenhagen and Sofia as our 2 test cities. And this is also where we are then implementing these use cases we are doing right now, and you will hear Nils and Nora speak more about that. So in Sofia and Bulgaria, we have Nosenet Park in Sofia. We have also another use case looking at where there can actually be planted more trees. And then there is a project called My Green School, which has been going on for some years, where we are trying also to map the trees and see the kind of impact that have in the neighborhood. In Denmark, we have 3 use cases also. One is looking into air quality in a quite busy road in Copenhagen. Then in Roskilde, which is a city here outside Copenhagen, we are trying to model what will happen if we replace a car park with trees. Well, it's greening actually, including trees. And then we are looking at a smaller city here in Jutland called Kolding, where we are kind of trying to apply all the different services to that city, and also to test the cost of providing services for a city like that. Because what we realized is that some of the big cities like Copenhagen, they have a lot of data already. And that would be the case of many of our bigger cities in Europe, while the smaller cities, they in fact don't have so much data. So the purpose of these use cases is really to follow up on the co-creation process, but also to test again the user requirements we set out to collect in the beginning of the project. And then, of course, to test all the functionalities of the 100K trees services, so it acts like an alpha testing by the users. And we are expecting all this to be concluded here during the next few months, because we are in the final year of the project. So I think on this slide, I will leave the word. I guess, is it Nils starting? Because I have one more slide, but that was more a backup slide actually. So I will stop my presentation here. If I can figure out how to do that. Let me see. Oh, I didn't even have to stop my presentation. Great. So Nils, you take over from here. Thank you.
Okay, thank you. Should I just press on from here, Lisette?
Yes, please move ahead, move on because
Okay,
now
yes,
it's
please.
your floor.
Next slide. Good afternoon. My name is Niels Bro. I work for DHI, and here we have an introduction slide to DHI, just so you get a feel for where I'm coming from. I'm a business developer at DHI. I think it was mentioned in the beginning. And DSI is a company that is associated and dealing with all kinds of water-related issues, water management issues, water modeling issues, and so forth. Also at DSI, 25 years ago, we started up Earth Observation Division back in the year 2000, and now we are hosting an Earth Observation Center of Excellence here in Denmark at DHI. The MIC modeling complex is probably what is best known for DHI is the modeling complex of numerical water modeling models that we have worked on for all these 60 years. Let's go on to the next slide, please. Yeah, so I'm going to tell you a little bit about how we use satellite data for assessing these urban greening decision tools and how we may use satellite data for this purpose. Yes, next slide, please. So first, just a little bit about satellite data. For those of you out there who may not know much about satellite data, it's important to understand that satellite data is many different things. Here we're looking at satellite data in the optical domain, meaning that these are satellite data that resembles something that you would be getting from a normal camera. To the left is Sentinel-2 Copernicus satellite. This is our workhorse, the one that we use by far the most. It's providing free data, but as you can see, compared to the picture in the middle, the data are relatively coarse. They are very high quality, but they're coarse, meaning that the pixel size is quite large. And to the right, in the middle, you see a commercial satellite image from the Airbus company, and to the right, you see a traditional aerial image in 10 centimeter resolution. Just to give you an idea about the differences. Next slide, please, or maybe just press on. Thank you. So here is a zoom in, so just to highlight these differences that I mentioned. Next one. Yes, thank you. You see, Sentinel-2, we can detect clusters of trees. We can see here is probably a building, and here is probably a road, but we cannot really assess the details. Next one, please. Next. Whereas when we go to a high resolution image, can you go back once, please? Yeah, when we go to a high resolution satellite image, we can detect the individual trees, which is important for this study that we have done as part of the 100K trees project. And also other smaller objects are detectable. And of course, with the aerial images is by far the best resolution. Next one, please. And we are actually within a few months going to see satellite data providing this type of imagery as well. Next one, please. Next, please. Okay, so here's one of the results from the project. We combine these high-resolution satellite data with artificial intelligence, are able to detect individual trees in the city. To the right, you see an example of a comparison study that we made based on our depiction of the individual trees and a comparison with the manually measured trees and their positions, and you see there's quite a nice correspondence. Next, please. So once we are able to detect each and individual tree in the city, it's very hard to get an overview. Where are the trees? Where are the green areas and such things? So here we use a hexagon aggregation mechanism to aggregate the trees within each of these hexagons to give a more clear view of where the city trees are located. And what you see here, the gray areas, this is Roskilde city in Denmark, the city of Roskilde, and you see very clearly where the gray areas are located. These are very heavily urbanized areas, typically the central parts of the cities. Next, please. So what do? We use this very high quality satellite image with 6 spectral bands, and from that we can derive and we can calculate and derive the vegetation density or the foliage density, and from that image or from that calculation we apply some Gaussian distribution functions, and based on that we can detect the top of each of the trees, and that position is then denoted the position of the tree, which you see to the right. If you click next, please. Yes, that's the vegetation density map. And the next, please. And from that we derive the position of each of the individual trees in the city. Next, please. Okay, so what is it good for? We have decided in this project to implement the 3-30-300 rule that was introduced for a couple of years ago to depict and to as a measure of urban greenness. Next, please. Yeah. So the 3-30-300 rule is a rule stating how green is the area in where the citizens live. The 3 refers to that each citizen should be able to see at least 3 trees from his residence. The 30 refers to that in the neighborhood at least 30% should be of green nature in the neighborhood, and the 300 refers to the fact that each citizen should have not more than 300 meters to a green area, a park, or dislike. And so what we do is we use our satellite-based tree inventory, and we combine that with the building footprints, so the machine learning model that we have developed, and some GIS, geo-operational techniques. Next, please. And we are then able to map out each of these components of the 3-30-300 rule. If you go to this is again the city of Roskilde, please, if you go to the next slide. Here we see the 3 score. In other words, where and from which residences are you able to see 3 windows if you look out the window, technically speaking. And what you see here is that's actually very often the case in Roskilde. However, some of the red areas in the center of town, they are not 3 trees visible from your window. But the idea here is that satellite data is a very nice data source for assessing these rules. with no other data would you be able to actually get this type of information at a spatial level, at a regional level, so to speak. Next, please. When we look at the 30 score, it looks a little bit different. This, of course, has to do with the way we define a neighborhood, and this can be done in many ways. In this case, we've used a radius and then calculated the amount of tree cover within for each position given a certain radius. And it does not look good in most cities, actually. So this rule is hard for most cities, at least in Denmark, to live up to, although we consider Denmark to be a relatively nice and green country, also in the urban environments. Next, please. And the 300 score. So this is actually a binary map. We put it into the scale, nevertheless, but for all the green areas, the citizens have less than 300 meters to the nearest green area. Again, this can be tweaked in the sense that you can define green areas in different ways. I think we used the OpenStreetMap definition of green areas and used that as a basis for the calculation. And of course, you see the red areas again located in the parts of the city where there's a heavy urbanization, typically the old parts and the industrial parts of the city. Next, please. And so we are also using the GIS, standard GIS tools, able to actually combine all of these measures into a total score. And so this tool is a very comprehensive tool actually to assess the greenness of a city at a particular point in time. First of all, it can be used if you want to see how you actually how your mitigation efforts are progressing. Does it provide the effect that was the intention? Is the city becoming greener over time? You can also use it as a baseline or for an intercity comparison setup where you want to see, I mean, you have a city, but maybe you have a city that is very nice and green, and you want to try to achieve the same greenness with your mitigation measures. And so it's a very comprehensive decision-making tool for creating livable spaces and green cities. And I think that will be my last slide. Thank you.
Thank you, Niels. Now we invite Nora to complete the second part of this presentation.
Yes, thank you. I will share my screen. Can you see this well?
Yes,
Yes.
not the presentation mode. No, it's okay.
Okay. All right, so my name is Nora van Kouwenberg. I am a professor at the university specialized in water and insurance value of nature-based solutions. And some years ago, I also co-founded a spin-off of the Brussels University called BetaGreen. Today, I am presenting our work on where to plant which trees, which is the work of my colleague Ali Aslami and myself. So in this project, well, before we go there, maybe some words on BetaGreen. So BetaGreen is a spin-off of the Department of Water and Climate of the Brussels University, and we started in 2020 with a mission to bring nature-based resilience to cities and assets at scale. And this actually was also a spin-out of another European project on the insurance value of nature-based solutions, NIAD, where we collected a lot of evidence of what is actually the exposure of climate and nature risks in cities and assets all along, and how this is also an insurance and assurance issue. So if we look at the financial risk that is linked to it, but of course also, and more importantly, the well-being problem that it generates. So the mission is to do something about it, and to do something about it harnessing the power of nature. And so Beta Green mobilizes Earth observation and high resolution modeling to help urban risk managers realize the benefits that are delivered by nature-based climate adaptation. And the way we do that is by modeling the different ecosystem services for different scenarios. And we then look into the cost and effects that that has, including social impact. In the 100K tree project specifically, we are working with VUB, so with the university we spun off from, to develop modeling tools for urban trees. And this is really important to understand better what are the ecosystem services that urban trees bring. And if we say ecosystem services, then we think about the cooling effect that trees can bring, the air pollution removal, noise control, stormwater management, and biodiversity improvement. And the reason why we are doing modeling is that if you want to improve your well-being and financial and climate risk on your assets and in cities, then you would want to understand a bit what if, right? So what if I plant trees in a certain location? What is going to be the effect? So we want to generate predictive capacity on a living infrastructure. So what we do is we model the impact of the trees, but we also model the way the tree grows itself. And this is a very important element that we have seen, and we also in the use cases in relation to the place, the location of where the trees is planted, the type of trees you have, but also the irrigation situation, whether the trees is undergoing a drought stress. These trees will perform differently, and it's important to understand what is happening. So we have been working at different scales. As Birgitte has introduced, one of the use cases in the 100K tree project is Roskilde. So here there is a situation where we have a large building with a big parking lot, and now we want to transfer that parking lot into a more green space. So the first thing that we have been doing is to set up the scenario modeling. So it's very important to clearly select which are the date of the modeling that we're going to look at. So we look at the historical data from the summer 2024, both for temperature, but also for the rainfall, and then consider different standardized tree types, where it is important to look at these standardized tree types for the leaf area index that they have, the height that they have, because of course, depending on the type of trees, you will have different impacts on cooling, on stormwater management, etc. So here are some results. So on the baseline modeling, what we did is to find some places to locate trees. So there's 10 parking lots that were given available for greening. And we put a permeable grass grid implementation with 7 trees that are small, a small size. So we have the leaf area index that is related to that. And then we're going to model the impact of those trees. So the first part of the modeling is on the flow conditions. So we are working with a wind speed velocity at noon, where the direction and speed is given. And then it's interesting, for example, to see already in this image, you can see nicely the effect also of the wind tunnel here that is created, but also some recirculation effects that are happening in this tree in the parking location. So if we then start modeling the heat distribution, so here you see the heat distribution in blue, we're at 26 degrees up to 30 degrees in red. You can clearly see that this location, this parking location in the baseline scenario is rather hot. And so there is definitely opportunity to do something about it. So when we plant these 7 trees, you can immediately see the impact of the trees. And we have a double impact. One is at the location of the tree itself. Yeah, we almost reduce the temperature by half, whereas the average the average temperature in this location, because of the presence of the trees and the mixing of the air, is also reduced by 1 degree. Likewise, if we go look into the flood model results, we again have our 3 locations, but we also have made these parking spaces so they have become permeable. And what we're doing now is we are modeling different return periods. The design storm here, 10-year return period, so it's something that happens rather regularly. It's often also an issue for the sewer systems. And what we are measuring in the baseline scenario is a maximum water depth with this type of rainfall of 45 millimeter. And we then do the same again with the trees implemented, and you also see quite a substantial reduction of the flood depth. And the reason for it is that the canopy of those trees is actually capturing a lot of the rainfall and it's delaying its release into the ground. On top of that, you have more infiltration in the parking lot that has now been made permeable. So even in a small site, we see interesting results. So up to 25% positive impact on the ambient temperature, even 50% if you go directly in the location of the trees, and up to 75% of reduction in the water depth. We can also model that at a city scale, so we can extrapolate these different models. I've now shown you only heat and flood, but we can also look at the biodiversity, noise, etc. And then integrate that in all sorts of decision-making tools. Yeah? So what is coming out of the 100K tree collaboration is a modeling framework, a modeling engine. At BITA Green, we will then integrate that in our platform, in our geospatial platform, so that you can assess risks for different tree planting scenarios, different green infrastructure scenarios, and different investments, therefore, under different climate conditions. And with that, the cities can address their climate adaptation challenge in a way that is as cost beneficial as possible. Thank you very much. I leave you the contacts here in case there's further questions later.
Thank you very much, Nora, for your presentation, and thank you all our 3 speakers in these useful insights regarding the 100K trees and the solutions you are developing for cities to make them more resilient. So I encourage our participants to leave any questions that you might have for our speakers in the comment section. Please remember that at the end of the second session, we will have a Q&A session so we can answer these doubts. So I think this is the end of the 100K tree session, and we will move forward with the next session, which is Buildspace. So for Buildspace, I'm happy to introduce 2 special guests. One is Stamatia Rizou. It's a research and development manager at Singular Logic. She's leading a team of 15 researchers in AI and data technologies. With over 10 years of experience in EU-funded research and development and with experience as a technical coordinator. She's currently the coordinator of Buildspace and the Inherit project. She's an MSCA Fellow in Cloud Computing, and she's a regular expert evaluator for the European Commission in ICT. Alongside Martina, we have Carla Rodriguez Alonso. She's a researcher at Cardiff Technology Center. She's an expert in urban sustainability, energy efficiency, and climate resilience, and she works on digital decision support tools for cities and buildings. So with this, I would like to give the floor to Martina, who is going to give an introduction to the Buildspace project, the mission, and how it contributes to energy efficient buildings and climate resilience for urban development.
Thank you, Lisette. Let me share my screen. Give me one moment. Okay. So thanks for the introduction. I will give a short overview of the Buildspace project, and as Lisette mentioned, my colleague Carla will present in particular our decision support services. So let's start with some background about the project. First of all, our motivation when we started the project has been that we see and we witness that cities are becoming more vulnerable to natural hazards and climate change effects, and buildings within the cities are a major infrastructure that needs to be protected and monitored, and it is important to provide some evidence-based decision support tools in order to support this transformation of the built environment to resist the climate change effects. So that has been our starting point, and our project, similar also to the other projects within this group, we want to tackle this challenge by providing tools that rely on data, on heterogeneous data, especially satellite data, in order to support evidence-based and data-informed decision-making. We are a 3-year project. We started back in the beginning of 2023. We have made already quite substantial progress, and we'll present you some of our results today. Our objective as a project has been to combine and to rely both on satellite data and also terrestrial data, and use these different information sources in order to provide tools to analyze the built environment within the cities. The main objectives of the project have been, first of all, in the beginning of the project, we started with a co-creation process with relevant stakeholders within the urban landscape. We also worked on a baseline infrastructure in order to collect different data and provide them to the services. And we worked, and this has been the main part of the technical activities within the project, to develop novel services, utilizing digital twins, but also city-scale services in order to analyze the urban environment. We test and evaluate all these services in 4 different pilots across Europe, and we'll say a few words about this later on. And of course, in between, we have tried to promote our results and disseminate our efforts. The overall concept of the project has been that we rely on a platform, what we call core platform, in order to provide access to the different heterogeneous data. And on top of this, we work on 2 main clusters, let's say, of services. One is services working on the building level in representing the digital twin of the building, and the enrichment of this digital twin to reflect the different aspects of the thermal envelope and different parameters. And we also work on the city-scale applications, covering aspects related to the simulation of different climate scenarios, their energy demand and energy supply, potential energy potential in terms of renewable sources, the urban heat analysis, and the urban flood analysis and resilience. For the city-scale services, we will have a dedicated presentation from Carla just after my presentation, so I will not focus on this. I will say a few words about our tools for the digital twin. Since our project is also part from the COSPACE projects, we work with Copernicus data, and also we use EGNS positioning for the digital twin positioning. So this has been an overview of the main key resources from Copernicus that we have used for the development of the services. For the development of the core platform. Basically, we have analyzed together with the pilot partners the different use cases. We have identified the data that are relevant for our services. We have developed an integration of our platform with this service in order to provide the data to the corresponding services. And we have also launched a platform to provide access to the different data that are used within the project. Both through a UI, we provide some manual exploration of this data, but also through a programmatic API access that it can be used from the services. In terms of the enabling service for the Buildspace project, as I said, we work for the representation of the buildings in terms of digital replicas. In order to create these digital twins, we have used data from drone flights, and we have followed a specific protocol in order to collect this data. And with this data set, we have reconstructed geometry of the digital twins of the buildings, and we have tested and evaluated different methods to detect and classify the building elements and create these high fidelity digital twins. The second service with relate to digital twins, it is about digital twin enrichment, and there we have used on top of the geometry representation, we have used RGB and thermal images that were captured from drones in order to create additional layers and representations for the buildings, and help the user to identify and analyze the thermal alteration in the building envelope, detect potential critical areas for the envelope quality, and also detect potential malfunctioning cells in case of rooftop solar installations. These digital twins, as I said before, we are using also EGNSS position in order to locate them within the city scale. And basically, as I said in the beginning, we test our services in 4 different pilot cities. In pilot 1, which is in Poland, we work mainly with the digital twin services, and this is the part that we are working in supporting through our tools the construction of the buildings, and this is the main focus. For the pilot 2, which is in Riga, it is a city scale pilot, we are focusing on the analysis of energy demand and resilience, and we test one of the decision, the city scale tools that will be later on presented. In Piraeus here in Greece, we focus on urban heat analysis. And finally, Ljubljana in Slovenia, we focus on urban flood analysis and resilience. Beyond these 4 cases, where we test different services depending on the profile and the needs of the cities, we also working on some replication boosters that will work in this final year of the project in order to help replicating our solutions in different cities. I think that is from my side, and now I could give the floor back to Lisette and then to Carla to say more things about the city scale services. Thank you.
Thank you very much, Martina, for your presentation. Now I invite Carla, who is going to give us an overview of the decision support services developed within the project, focusing on the key features, the applications, and the real-world benefits for urban sustainability and resilience. So, Carla, welcome, and the floor is yours.
Yeah, thank you. So, all right, we are going to focus in this decision support services. So, first, we start with a question: why decision support tools matter in urban planning? So, first, because urban areas face increasing climate challenges. Also, because decisions should be informed by accurate, spatially aware, and scalable data. And then Buildspace delivers tools that integrate ether observation and AI data to support cities and stakeholders. And as this EA report says, policy and planning decisions often lack access to timely, location-specific data and tools to assess climate risk. So this is where Buildspace finds its place. So as Martin already explained, these are the decision support services that we are developing in Buildspace project. At building level and at city level, we are now going to focus on the 3 services at city level because they are more decision support for urban planning at as a wider scale. So first, the built environment climate scenarios. It is a service that models current and future energy demand of the residential buildings. It projects the demand under climate scenarios, so it can be assess the current and the future demand, taking into account different future climate change scenarios. It also evaluates the rooftop solar PV potential, so to assess the installation of PV panels. And it also simulates the retrofitting strategies and quantify the improved energy demand with this application of the measures. So here in the map you can see just the map of the city of Riga and how the buildings are rated according to this scale based on the APCs of the city of Riga. The decision value is that it supports the long-term energy planning, also building stock renovation strategies and the solar energy deployment with we could say less climate uncertainty. We have this other service, which is urban heat analysis and resilience. So it assesses urban heat exposure using microclimate, demographic, and socioeconomic data. So this combination of data, and it identifies also vulnerable population and urban heat island effects. It also estimates the cooling energy needs and supports the classification of heat risk zones. This is developed in the Piraeus in Greece. And it has a decision value because it enables design of target adaptation actions and cooling strategies to reduce the urban heat vulnerability in the most stressed areas. And we also have this urban flood analysis and resilience service. So it calculates the flood damage risk to buildings and under different scenarios as well. It identifies vulnerability hotspots, and it also assesses the impact of the blue-green infrastructure implementation and other adaptation measures to flooding. It also provides the scenario-based visual outputs to support the planning of these most vulnerable areas as identified, and compare scenarios with the created damage layers and so on. So the decision value is that it informs flood adaptation strategies, infrastructure investment, and planning decisions to enhance the urban flood resilience. So here we say from data to actionable insights, because its service transforms geospatial data into actionable indicators and visual outputs. It supports evidence-based planning, risk-informed decisions, and cost-effective investments. And they are designed to work with real city data. So the 4 pilots in Riga, Piraeus, Ljubljana, and in Poland. So yeah, here you can see how the comparison of 2 selected layers can be done, and also the different graphics and scenarios created by the user. So also this provides a real world impact, because the different services, for example, the service of the heat urban analysis in Piraeus, it identifies the urban heat risk zones and support the targeted adaptation measures. For example, in Riga, as we can see in the screen, they can test passive retrofitting strategies under current and future climate conditions to support evidence-based renovation planning. So here the comparison between the current scenario and the scenario with these applied retrofitting measures. And in Ljubljana, because it evaluates the impact of the blue-green infrastructure solutions on flood risk reduction. So now what's next? So we are on our final deployment phase, which is due in June this year. So just in a few months, the services are quite well advanced, and we are in the mainly in the testing phase with the pilots. They will be accessible all through the core platform, and also we have opportunities for replication in other EU cities and integration into urban planning workflows. So speaking of replication, we have this open call for the replication potential assessment. So the selected organizations can apply, and then they will explore these decision support services, participate in training sessions, and understand how these tools can be adapted into their local context. So the call is open until the end of April, and yeah, we encourage you to spread the word and apply, of course. Yeah. So this is all from my side. I think the questions are at the end, but happy to take any questions.
I think thank you very much for that presentation, Carla. And again, I encourage participants, if they have any questions, to put it in the comments part. Since now we have finished both sessions in our webinar, we are not going to open the next session, which is the questions and answer. And for that, I'm going to share my screen, and I'm going to give the floor to my co-moderator, Alessandra, because she will guide this next Q&A session. Alexandra, the floor is yours.
Yes, thank you very much, Lizette, for the presentation. And so we are perfect in time, ready for this Q&A session. The session is organized in this way. I will do a question for each speaker, starting from 100K trees. And after that, if we have time, but I think so, we will answer the questions from the participants that you can put in the chat. So after that, we will draft some conclusions from the 100K trees and Buildspace perspectives, as well as from the COSPACE project cluster perspective. So I see all the speakers here, and I can start with the first question to Birgit. Hello, Birgit. So the question for you is, what are the main assets to achieving the overall impacts of 100K trees project? I mean, are they more technological, or do they stem from other factors? Thank you.
That's a good question. I think it's a number of issues, and I think it varies from city to city, because the reason actually we called it a 100K tree in the beginning, because that was inspired by Copenhagen, who had a plan to plant 100,000 trees in Copenhagen. And this is, well, I mean, when did we write these proposals? It's almost 4 years ago, isn't it? So at that time, we were told that they also had a problem with financing the 100,000 to plant the 100,000 trees. That now might not be the biggest issue. Now it's probably more that, you know, there will be a fight with citizens about removing parking places, and so it's really a matter of also finding the right places to plant the trees, because you are competing with space in the city. In other cities, it might be an economic problem, smaller cities who doesn't have a huge budget, who doesn't have lots of tourists and so on, which has a more limited budget. There, of course, it might be a problem. And that's also why we were looking into these kind of other types of financing mechanisms. So maybe to work with private companies, companies who have office facilities in the city, because that it's also in their interest that it's green and that their employees enjoy, as we could see in the 300. I mean, the impact of trees and the well-being of people, and thereby their productivity, is also quite well known. So there's many kind of aspects and benefits of planting trees. So it should be possible to finance it also in another way. So I think, you know, there's different problems, different issues in the different cities. We know also in Sofia that one of the problems there is that, I mean, in fact, Sofia is extremely green. If you have ever been to Sofia, I mean, it's an extremely green city, greener than Copenhagen, which was a big surprise to me, actually. But it's old trees. So when you have city development there, you will have to chop down some of these trees. So there, in fact, it's the maintenance of the old trees, which is a problem. And also that they will probably be chopping down a lot of trees in the future if they are doing city development. And that, again, is really bad for the air quality and all that, which is already really heavy in Sofia. So there it's more a matter of maintaining the trees they already have. But how do you do that if you also want to develop the city? So you see, there's a lot of political, economic, space, you know, lack of space and stuff like that issues, and they vary from city to city. That was a long answer. I hope that satisfied you.
Yes. Thank you very much. And we approach these problems also in a 100K Trees webinar we organized in November with the city of Genoa, where we went through many problems in the Genoa city in Italy to improve the green in the city and plant trees. So we in our city, in the city where personally I live, we have many other problems. So yeah, thank you. And so the second question is for Niels from DHI, and it's a more technical question since you spoke about satellite data and Copernicus data. What are the strengths and limitations in using Sentinel data to map trees in a city? Hello, Niels. You are
okay. Here it was. Sorry, I was trying to unmute. Thank you, Alexander, for the question. So the question was, what are the advantages or the by using Sentinel-2? Can you repeat the question, please? Hello?
Alessandra, your mic is off.
Sorry. Okay, I was asking you about strengths and limitations in using Sentinel data to map trees in a city.
Yes, thank you. I think I showed a slide in the beginning of my presentation showing the strengths and also some of the challenges with different types of satellite data. The Sentinel-2 data that we use, the data from the Copernicus program, are very, very comprehensive data because they're often renewed. So often there's a satellite passing over, and this increases the chances of actually getting cloud-free and good images to do calculations upon. On the downside is that it's difficult to detect individual trees, as I think I showed on one of the slides. And for that purpose, we need to go to commercial satellite data, which we have to pay for. They're not very expensive these days, however, but still they're not as frequent. However, they are very, very comprehensive in terms of making these tree assessment and tree metric studies that we do, and assessing how much canopy cover is present in different areas of the city, how many trees are present, where are they located, and all of these things. So there are pros and cons for different types of satellite data. The Sentinel-2 Copernicus data are really very good to generate time series of an area. See, is it greening up over time, or is it not? Because the data are so frequent, for instance. Yeah, I think I'll leave it at that. Unless there's a follow-up question, please go ahead.
Your mic is off, Alessandra.
Yeah, sorry. Okay, so thank you very much, and I invite the participants to interact with the questions if you like. And I have a third question to 100K trees to Nora. Nora, are you connected?
Yes.
Okay. And so the question for you is again a technical question. In your opinion and in your experience, the 100K trees simulation tool can be further developed. I mean, by adding new features, new scenarios. For example, to cope with specific needs of a customer city, because you know, and I imagine you understand these specific tools is addressed to cities for urban planning and to improve the so their manage of a city and management of trees. So yeah, Nora, the floor is yours.
Yes, thank you, Alessandra. Yes, the tool is customizable. Let's say that the way it works is that there is a data management component. Yeah, so we have heard from DHI the different data options that are there. This is a first choice that a city can make. Maybe they have their own data that want to be integrated, or we use either publicly available data or commercially available data. And the other part of where you can optimize or customize is which type of modeling or which kind of assessment to do on those trees. Yeah, so are you working with are you interested in heat? Have we seen the example of Pires? Or is there maybe more an issue with flood or even health? Yeah, so there's different options of choosing what to do. One thing that we have seen in collaboration with cities and conversations with cities, and I think everybody relates to that, is that you have to find space, right? So the trees or nature always compete with higher value land, because nature in cities is a cost on a balance sheet. It's not an asset. So first off, you have to find the physical space for it, and then you have to find a budget for it, not just to have the capex, not to plant a tree, but also to be able to maintain that tree over time. And so one thing that we are seeing in Beta Green and in conversations around 100K tree is that there's a lot of interest in having prolonged monitoring of urban green vegetation to optimize the management of it, the maintenance of it. And I think also there's a lot of value in using higher resolution, temporal resolution, also space assets to inform that properly, yeah? So that cities can have a good balance between using remote sensing and ground truthing with their maintenance teams to go and make sure that urban vegetation is in good health, because only when it's in good health, it will be able to perform well. So that's the challenge that we are seeing coming next, and where the development will go into. Thank you.
Thanks to you. And yeah, I guess many of the data used by these simulation tools are open data and data coming from the public administration. So in terms of scalability, we must say they are applicable to the majority of cities in Europe, having data for sure.
Yes, and in Europe, we generally have a rather good data environment. Of course, you do need to have some data that are to be provided by the city, notably cadastre data. So where are the buildings located? What is the parcel delineation? Is this a public or a private lot? This is really important because it also really defines the decision space. For example, we have been working with a city that had very specific regulation, even at district scale, but also generally of historic buildings where even if they would be suitable for green infrastructure implementation, it is not allowed. So you need to have this kind of information in addition. But overall in Europe, the data environment is good, again, with the caveat of what I think Niels has shown very clearly, that you do have a different you do get better quality if you use certain commercial data products.
Okay, thank you very much. And yeah, we can pass to the Buildspace speakers with Stamatia. And so I have a question for you. How do envision Buildspace impact in the long term, and what are the next steps to ensure these solutions are widely adopted by cities across Europe? Thank you.
Thank you, Alessandra, for this question. We hope that we will contribute with the services we have developed in Buildspace. We are now in the final year of the project, and we are quite advanced with the implementation of the services. So currently we are focusing on creating some replication guidelines on how these services could be potentially replicated in different cities. Of course, as also previous speakers mentioned, we do use satellite data and also Copernicus data in particular for our service, but we use also some other data that are provided from the cities, and that's why in each case we need some tailoring and some adaptation, let's say, to the specific urban context. So the focus from now on is to create this comprehensive replication guidelines and also test the way that we can support this process. We are also right now we have an open call for replicators, so cities that might be interested to learn more and about our services and explore in more particular how we can help them to use our services. We have opened a call that will run this period and will work with cities beyond the 4 pilots that we already have in the beginning. And we hope that through this process we will have also will update some best practices and some blueprints in order to fine-tune our replication guidelines. Also, beyond this call for replicators, we envision by the end of the year to have to organize also a hackathon where we invite external developers or interested stakeholders to use parts of our service in order to develop, to fine-tune our services or develop some new features. And so we see a potential in different aspects, both in the case of cities to adopt our services, but also in the case of the entire ecosystem of developers to use our technologies in order to create new features and support further our vision. That is from my side. Thank you.
Okay, thank you for your answer, and yeah, let's say congratulations for your robust exploitation plan and the replication plan. So I have a last question for Carla. That is our last speaker, and then we have a question from the chat. So for Carla, how have Buildspace decision support tools been received by your pilots? And what are the main barriers to their integration into real-world urban planning? Thank you.
Thank you for the question. So yeah, the decision support tools have been well received by pilots because they provide actually added value and data-driven insights for urban planning, for climate resilience, and also for the adaptation of the different infrastructure at urban level. But it is also true that our main barriers or challenges relate with the integration of these tools into real world planning. So mainly data availability, because yeah, there are different countries with different data contexts. Open sources is not always the only data that we need to use, so we need to combine and look for more detailed data. So there are also these technical complexities, the need for the alignment also with the existing planning workflows and policies, and also of course the stakeholder engagement and capacity building are crucial also for this successful adoption, let's say, that for the services to be really used and to make really a difference in the real world application. So yeah, also we are trying to promote this ongoing open call to address these challenges and promote the wider integration across Europe and yeah, other European cities with similar challenges to our pilots.
Thank you very much. You touched a very important point, that is the capacity building and the skills for the operators to deal and to use such a tools. It is not an easy step in particular in cities and in public administrations. Okay, so I have from the chat a question for Nora. If you are connected, it's quite long. Did you have an opportunity to study the effect of urban forestation in function of the tree growth cycle? Namely, are there percentage reduction numbers that you have presented, the peak numbers? If so, is there a good idea at which point in time would these effects reach their peak and would they diminish in time?
Yeah, that's a very good question. Indeed. So we are looking at the development of the leaf area index over time for different standardized trees. And what we have shown here is the peak, but for a small tree. So we have it was a tree of around 3 to 4 meter canopy, I believe. And what is important is indeed to show that normally these trees will take, depending on the type of tree, it will take them 15 to 20 years to get to this peak performance, right? So you have to plant, you will have to foresee some time to plant. And this is one of the conversations we have had in Sofia, is which size of trees or which age of trees will you be planting? Yeah, so they have a nursery where they will go and grow the tree up to 15 years and then it is planted in the streets. That is, of course, also not always possible. Is it a good idea? At which point in time would these effect trees peak and would they diminish in time? So the diminishing in time again goes with the normal life cycle of a tree, depending on the trees. They can grow easily 100 years old or more, but often in cities they're not let to be grown that old. The diminishment in time that we are most interested in is if the tree is under stress. Yeah? So not necessarily because of old age and going into decline as such, but a tree that is under severe drought stress will also, in extreme case, even lose its leaves. And then, of course, the ecosystem service that it provides will not be the same. But more importantly, or more a concern for tree planting in cities could be that this tree is then at the risk of falling and damaging the surrounding infrastructure. So that's why we believe it's really important to include indeed the growth of the tree and to acknowledge that this is a living infrastructure that comes with its complications, but that can also be managed if it is understood well.
Okay, thank you very much. And I don't see any other question from the chat. And so I think you are always the possibility to get in touch with the speakers. You have the email address, and also we will publish just the time to arrange the web pages. We will publish this webinar on 100K Trees and Buildspace website, so it remains. And I think we can go to the conclusions. I will draft some conclusions from the perspective of the two projects, 100K Trees and Buildspace. And at first, I would like to thank all the participants. You were a lot more than expected, so thank you very much for your participation. And just to highlight a little bit the key points we touched in this webinar, and to offer you reflections from the point of view of these two projects, 100K Trees and Buildspace. At first, my first consideration is the urgency to deal with climate change. It seems it's certain that cities are the first places where climate change have impacts, and for this, urgent and prioritized interventions are necessary, especially those aimed at achieving well-being and risk reduction goals. So projects like 100K Trees and Buildspace are extremely important because they offer targeted services to design solutions that align with future climate scenarios and scalable, and they can be immediately applied in different contexts and European cities. So the second consideration is about the approach. Progress and innovation of a city bring together various elements from the technological, social, environmental, and economic point of view. All of them are interconnected. That's why a truly holistic approach is essential, and at the same time, the support of data-driven systems is crucial to assist decision makers and policy makers. My third and last consideration is about technologies, since the Buildspace and 100K trees and also the COSPACE cluster deals with the Copernicus. They are founded and managed by the EU SPAN agency of the European Commission. So my consideration is that satellite data and remote sensing are well-established technologies in environmental, territorial, and infrastructure management. However, their full potential has not yet fully exploited, which means that there is still room for innovation and development in this field, and for sure for business. These are my conclusions from, as I mentioned, from the perspective of Buildspace and 100K trees. And if Ben Moore is available, is still connected, I will leave the floor to him for conclusions on the COSPACE project clusters point of view.
Great, thank you, Alessandra. I think you really kind of covered most stuff there with your closing remarks. But before we finish up, I just want to reflect briefly on what the COSPACE webinar series, not only today but both webinars has kind of shown us. So over the course of the 2 webinars, we've seen how 5 very different Horizon Europe projects, each with their own goals, teams, technologies, etc., are able to come together around a common mission under Horizon Europe and to use space data and AI to tackle climate changes in smarter and more integrated ways. Over the course of the 2 series, we've explored everything from energy forecasting and sustainable agriculture to forest monitoring and urban greening. And what's been clear is that collaboration like this isn't just something that's nice to have. I think it's essential if we're looking to build impact that is both lasting and scalable with our 5 respective projects and what they hope to achieve. So COSPACE has really helped us to share our tools, our ideas, and our audiences, but also just to think bigger in terms of the scope and the scale of what we hope to do. And hopefully as well, for those of you watching, it's kind of sparked some ideas about how your own work or your own interests or expertise might align or intersect with what we've been doing across our 5 projects. So that's really all from me, just some kind of closing remarks on the COSPACE Group and the webinar series. And I want to thank you all for your attention. It's been great.
Yes, thank you very much. I have a last question in the chat for you, Ben, asking about the registration of the first webinars you had in March. And so I suppose, yeah, it will be available as well.
Yeah, sorry, I can't see the actual question, Alessandra. What's the actual, are people looking to view it or?
No, because it's to me.
Oh, sorry. Yeah, if anyone's looking to view the first webinar that we had back in March, that it was recorded, and our plan is to upload the link to that across our social media channels in the next week or 2. So that'll be made available on the Respondent Project's social media channels, as well as the Magda social media channels. So that'll be available for anyone to view that wants to see it and what we discussed during the first webinar in the COSPACE webinar series.
Yeah, so I invite all of you to visit the websites of 100K Trees, Buildspace, and also Respondents. But for example, from 100K Trees, we have a page dedicated to the cluster projects, so you can get access also to the other websites, and you will be informed as soon as this webinar will be online through our channels. And so I renew my thank you to all of you for participating also on behalf of all the organizers, and many thanks to all the organizers and the speakers for the successful event. Okay.
Thank you, Alessandra. Thank you, Lisa. Thank you, Ben.
Thanks a lot,
Thank
for
everyone.
organizing.
Thank you all.
Thank you,
Bye
everyone.
bye.
Bye.
Happy Easter.
Bye.